Welcome to the ET380 Transistor Biasing and Transistor Amplifier Configuration lecture video. Okay, here's our first transistor biasing circuit. Is base bias, or what we call fixed bias. And we have our NPN transistor with a base resistor, a positive DC voltage on the base, and a positive DC voltage on our collector resistor and collector. This one is the least stable of our biases. Temperature changes, voltage gain. Voltage amplification dependent on beta of the transistor. Different transistors have different gains. Cannot substitute transistor replacements. Here we have transistor biasing, a feedback bias. And we have a minus voltage on our emitter and a plus voltage on our collector. And our base is grounded through our resistor. This one wastes power and energy, cannot go to full DC load line, and we cannot get full voltage out. Okay, here we have our voltage divider bias. And it's a voltage divider because we have two resistors which divide our voltage into the base. So we have a collector resistor, emitter resistor, and our NPN transistor, and this is the most common use. So this is most modern equipment use this type of bias. It's got good thermal stability, it's easily biased, and can easily change transistors. Voltage gain is not directly related to beta. Okay, let's look at transistor amplifier circuit configuration. This first one is a common emitter amplifier, and it is a NPN transistor. It is the voltage divider biased, and we have the output coming out of the collector. And it's sometimes called a collector follower, and we have 180 degrees out of phase with the input. We have high voltage gain, low current gain, low power gain, medium input impedance, high output impedance, and this was normally biased class A. It's a linear amplifier and conducts for the full 360 degrees. The input is on the base, the output is on the collector. Our next amplifier circuit is a common collector amplifier. So again, an NPN, voltage divider input, and we have the output coming out of the emitter. So we have a high input impedance, low output impedance. It's called a power amplifier, called an emitter follower. Voltage gain is slightly less than 1. Power gain is equal to beta. It's good for DC and low frequency use. Can be cascaded, such as done in a Darlington amplifier. Input and output are in phase, and the input is on the base, the output is on the emitter. Here's our common base amplifier. And this is the one we're going to do a lab on. And this is normally used in radio frequency circuits. It has high voltage gain. Input and output impedance is variable. Input and output are in phase. And it conducts for 360 degrees. The input's on the emitter, output on the collector,